Yeah, my name's Rupert. I'm going to talk today about building humane interfaces with language models. I'm really excited to do that. It's great to be here. I'm glad this is a really interesting conference and great to have this opportunity. So I've got some history working with language, well, not language models, but just AI models in general, and looking at, okay, how do we bring the humans into this picture, and what is use cases? Because these models are very much research driven. They're not necessarily user problem or interaction driven. And so some of my past work's been involved in bringing in writers or artists or musicians, looking at sort of where the models are and where that gap is, and trying to close that gap and see okay, how do we build something that's really useful and fits into a workflow and can elevate and bring new perspectives on creation. So at the moment, I'm working at Mozilla. I was doing some of that work previously with Google and other folks. Joined Mozilla, and I'm working in the Innovation Studio group there. This is a website. You can go check us out and some of the work we're doing. But basically, taking an approach to looking at what's happening in AI at the moment and looking at sort of new products. I mean, the studio in general works well beyond AI. New products and also ways to contribute to the ecosystem of tools as well. Yeah, so that's the topic I want to talk about today is a sort of narrative I've seen emerging around use of natural language and what some of these AI language models are going to do to change computing. Sort of some opportunities I see in that space for reimagining how we interact with computers. And then examples that I found that sort of illustrate some of this stuff, and also a demo, because demos are awesome. So this is a photorealistic depiction of a large language model, as you can tell. And we don't have to go in depth. I'm assuming some degree of prior knowledge. I'm assuming people have used these, maybe used ChatGPT, stuff like that. But basically, we can shorthand think of these as statistical systems that look at a bunch of language, find patterns in them, and are thereby able to take text in as an input and output what the next bit of text would be, because they've internalized some of those patterns. So this is sort of where they're at the moment in terms of how we interact with them. This is ChatGPT, and AI is definitely clearly having a moment. This sort of, I think, there's been work building quite slowly, but this was the real inflection point where a lot of people got their first interaction with these models. And as you can tell, this is a text interface, and it's a chatbot, because these models take text and they output text. So this is when we come to the narrative, because this is something that I've seen starting to really take hold, a narrative how the future of interface are going to work because of these tools that we're seeing emerging. A lot of folks, and I don't think text is necessarily a bad interface. There's some really useful things in, for example, these chatbot-style interfaces, but the sort of conclusion is that text is the ultimate interface, that language will be how computers work in the future, and that is how we will interact with our machines. And it's not that that's a bad picture, again. It's more just that you've got to be careful with narratives because they can constrain you. And if just having built this technology, we're saying okay, it's all text, then we stop looking outside of that box. And when I think of text, I kind of think we've been here before. This is very different. This is Microsoft MS-DOS from the 80s. And this is a text-based interface. Text goes in, text comes out. And the reason, and as you can see, we're kind of in a similar area. I think possibly the MS-DOS interface gives you a little bit more context, because you at least know you're in A. Whatever that means, but we're sort of echoing the past a bit. And I like to think the reason that we have these interfaces, and this is a little bit hand-wavy, if we go back to the 40s, this is the ENIAC computer. It's regarded as the first sort of digital computer, basically. And you interact with this computer by pulling out these chords and plugging them into different areas. That's kind of how you write the program. And then you have a punch card, and you've sort of probably seen these. You like punch the cards with like a sequence. You hand that to the computer operator. You go away, and then you come back and you get a punch card back. So why punch cards? My hand-wavy explanation of this is like, think about the structure of something like ENIAC or a computer in general. It's like a linear bank of memory and some operations that act on that memory. And in a way, that's kind of structurally similar to a punch card. It's like a linear series of instructions. It's easy to translate from like punched holes to what the computer is doing. And so that's the input-output. That's like the first interface that we build with these new technologies. And so you might think of this sort of like spectrum from the computer on one side to the human on the other. And in fact, text is a really natural interface for computers, as is like punch cards. It's like a natural fit. But we want to sort of move across that spectrum towards a natural fit to humans. And as we go forth, we start getting the graphical user interface, which is not a natural fit for a computer. It incorporates like a lot of stuff you have to deal with. You have to draw things on the screen. You have to like understand like clicks and locations and sort of map all of this stuff to that linear computer space. But it's a great fit for a human, or at least it's a much better fit in many ways than text. Like there are a lot of reasons. You can sort of dig into that. You can get real-time feedback from graphical user interfaces by moving stuff around. You can multitask easily. You've got this like spatial reasoning that humans are really good at built in. You can even have like metaphors like filing cabinets, which were popular at the time. It was easy to like learn. That increased the learning time. Decreased the learning time. And so the spectrum sort of starts to look like this. You kind of get the picture. And we're here right now with language models. They take language as an input or text as an input, and they output text. But what does this look like? This bit. What does it look like when we move away from just thinking about, okay, what's the input and output structure, and what is the structure that we want the user to be able to interact with? And I think all technologies, there's some delay between what they natively take as an interface to what we start to experiment with. So in the title of this talk, humane is a deliberately chosen word. It's used in the sense that Jeff Raskin used it. He wrote a book called The Humane Interface in 2000. And I'm just going to read out this quote because it's a great one. Use a machine in accord with its strengths and limitations, and it will do a good job for you. Design a human-machine interface in accord with the abilities and the foibles of humankind, and you will help the user not only get the job done, but also be a happier, more productive person. So we don't want to just build an interface that like fits the machine. We also want to think about, okay, what's the shape of the user, and how do we build an interface that fits that? And there are these two parts that we need to look at. So yeah, the question is, what's this human part? I'm going to throw a couple of examples. This is like a little bit of a palate cleanser maybe, and just a way to sort of look at some divergent ideas about what we can do here. The first one is very innovative. It's called a button. You may have encountered these before. It's like a simple example, but it's really useful. The idea of just putting a button this button in this case, this is GitHub Copilot. It's taking some text, and I can hit a button to make my code more readable. And what's useful about this is a couple of things. One, it's discoverable. Unlike a text interface, I can actually see what I can do. In fact, we still don't even really know what large language models can do. The people building them don't know what they can do. So they're inherently hard to discover, but we can make some of the functionalities that we've discovered more discoverable for end users. And also, it's fast and it's repeatable. So if I find something I want to do, I can do it again and again really quickly. I can just hit a button in a GUI. It's already an improvement to this total natural language way of interacting, which would be like copy the text, say, please, can you make this more readable? Can you even do that? It's just right there on the page. So that's like an antidote to this. This is not how we want to interact with computers. We don't want to have to ask every time we want to do a really simple thing that we want to do repeatable. It's like the wrong fit. So it's the wrong interface fit. This is a great example when you take this idea of brushes or like visual metaphors and apply it to language. It's an example of a tool built by Linus Lee. You can find him. I'll put the slides up on my website, by the way, if you want to take a look at this and dive into the links. And this is taking our ability to, I won't go into the details of like exactly how it works under the hood, but you can use these graphical metaphors to like drag text out and get these language models to change what they are. So that's something new that we can do that like diverges from what we've previously been able to do with interfaces. Really simple example, this is an app called Trip Notes. I can get a text message from a friend. I can just put it in this text box and get a map out. And this is like thinking about, I like to think of this like crossing wires. So one of the things these models can allow you to do is basically get one format of input and then output something else, like whether that's asking a question and getting code back. In this case, I can chuck in a text message and get like places extracted from that without really knowing, like I don't have to format my input in a certain way. The model can extract what it needs to and put that on a map, which is something that a computer can understand. Another great example by Matt Webb is this clock. The input here is the system time on Raspberry Pi, and the output is a poem. So again, it's this idea of like crossing the input and output wires. Another photorealistic depiction. I don't have an image for this one, unfortunately. It's a project a bunch of my some friends and colleagues did, where this one's interesting because there's not really an interface. It was for a building project at the Australian National University in Canberra. And the inputs are a bunch of sensor data like temperature, carbon dioxide levels, the ambient sound around the building. And the output is music. And what the model is doing is it's being fed all this data, being given some idea of how to interpret the data or what it means, and then thinking of like human emotions that might describe how this data makes it feel, or like what it associates with that data, and then finds some music that has been labeled and selects a musical track, basically, or puts together one by itself. So I like this one because the model's not even there. You don't know you're interacting with a large language model. You're not putting anything in a text box at all. It's just using the like ability of this model to understand some of these subtleties and translate into this interesting way to do this stuff under the hood. One takeaway for those designing with these models might be that it's useful to think of them not just as text in and text out, rather to think in terms of anything you can turn into text in, and then anything you can create from text out. And it turns out a lot of stuff can be transformed into text and fed into these models, and vice versa. I think there's something deeper here, though, and there's something, maybe if we look a little bit further into the future, that we can start to approach that goes more into some of the like great themes behind this Causal Islands project of like a new sort of computer and how that can change. If we go back to this Jeff Raskin quote, no, get rid of my mouse there. Oh no. This actually proves my point that I'm going to make later on. Use a machine with its strengths and limitations. It will do a good job for you. So what are the strengths of language models and how can we use them? Go away, menu bar. There we go. Okay, the mouse is just going to live on this page. I think something I identify as a big strength of these language models is they can take the messy human world and turn it into something computable. They can take a lot of vague stuff, natural text, or whatever it is, and find a way to create something computable from them. That's actually something that we haven't been able to do before up until now. And I think it's something quite unique. That's going to have some cool consequences. One reason I'm really excited about this from an interface perspective is that we're used to not having computers understand anything vague or messy or something that's not clearly defined. We're used to specific menus with certain options that are defined for us and apps that live in windows and files that can like only live in one place and they're not, and folders, but the metaphor of the folder breaks because you can't even pass it to someone, you've got to put it on a memory stick. Like the computers right now are full of broken metaphors and results in a lot of frustration for people using them. Contrast this with the natural world. This is a field of chamomile flowers. What can I do with this? I could pick one. I could pluck some leaves, petals. I could make a tea from it, or try make a tea and discover it tastes great. I could put one in a stream and let it float away. I could take one and give it to a friend as a gesture of love. I could try and make some sort of ink from the pollen. I don't have to check whether I don't get an error. I don't have to check whether chamomile flower is compatible with stream. I can just do it. And there's infinite possibilities. I can do whatever I want. The computing world is very unlike that. But maybe it could be a bit more like that. I don't think we can necessarily go all the way straight away, but why can't computing just be a little bit more fluid and have some of that aspect of natural interaction with the real world that we love so dearly and that enables us to do so much and feel really empowered? Lose some of that rigidity. That's where I think there's an opportunity in terms of these models. One smaller slice of that is this idea of that kind of echoes this already pre-existing idea that echoes some of this as adaptive user interfaces. I just like to call it flexible computing. I kind of just made that up when I was writing the slides, but it felt a bit more all-encompassing. That's user interfaces that adapt according to the needs of the user and the current context. There's been some sort of projects, experimental projects looking into this before. This is Mercury OS by Jason Yuan. There's also Wonder OS, which is a really cool one-person project looking into how operating systems could be different. And in this particular screenshot, you've got these different modules being assembled based on user intent. So you've got user intent being the primary sort of interface that then the interface forms around. So I'm sort of looking at, those are theoretical ideas at the moment. How can we actually make this happen with language models? I'm currently building a project called LangView, and I'm going to share a little bit about it quickly. This enables a model to output not just text, but also user interface elements appropriate to what it's been asked to do. So it's a sort of little step in this direction of a more flexible computing environment. This is what model output might look like, a sort of really simple description schema of an element. And then that can then get taken by whatever interface you're dealing with, whether that's the web, whatever component you're writing it in, and then presented in many different ways by a designer. Well, designer basically creates the components and the computer can present that. So here's what that looks like in practice. Let's see if this is going to start playing. There we go. So I'm going to Italy mid-year, and so I'm going to start asking about some ways that I can say hello in Italian. And after a bit of thinking, what I'm going to get back is a list. But it's an actual UI element. It's got a title. It's just a nicer format than getting a chunk of text. I could also ask, what a couple of great Italian dishes. How are they made? And then when I get a response from that, again, it's not going to be just text. In this case, it's going to be 2 card elements. And would have liked these to have some cool pictures as well, but I haven't quite gotten there yet. And it's just a better way of getting that information, basically. I can also ask, where is Rome? And in response to that, I get a map. And I didn't have to get the model to program this map from scratch. It's just a Google Map component. It could have been implemented by any map component. It's interactable. I can actually interact with the map right there on the page. And I might also ask, okay, well, when I'm over there, what are some cool landmarks to check out? And then I'm at LAX doing this recording, so the Wi-Fi is really bad. It takes a while. But eventually, we get back a map as well as a list that I can actually interact with. So I can then click some elements on this list, and the model has data-bound the list to the map UI, just really simply, just in the text schema that it's output. So it's just a small example of how interfaces could be a little bit more fluid, how they could be formed based on user queries or based on just user intents in general, and how large language models in particular have some of the power to be able to make that happen. Or at least it's worth exploring a lot more in a lot more detail. And yeah, where do we go with this? The answer is I don't quite know. This isn't like a well-defined future yet. We're kind of making it up. And hopefully some of you will join me in thinking about this a little bit harder. But I'd like to see a computer that's flexible, so that can be more adaptive and not run into so many hard, rigid edges as a computer user. One that's proactive in the sense that it can help me do stuff. Maybe I get an error message and it actually tries to work out how to solve that error for me rather than just saying something's not compatible. And also something that's sense-making. That is, the computer can like make sense of vagueness and the human world that I live in, and not force me to constrain my world to fit the computer. Might also add to this that also this would then allow users to have a bit more agency over what they're building, and allow end users to essentially be able to author programs and operate computers a bit more fully. This is just to point out that this is all still question marks. This isn't I don't have a picture here saying this is the endpoint, but this is at least somewhere we can explore. And at the very least, just try a button in the stuff you're working on. It might, increase the usability a bit. There you go. Thank you very much.
Thank you, Rupert. And we have time for some questions. Yep, coming around.
Have you started accounting for large language models hallucinating already?
Yeah, so that's going to be really interesting if you get them to build UI. One thing I forgot to mention during the talk is I was focusing there on the strengths of the models and deliberately ignoring the downsides, partially because I maybe need a longer talk slot to talk about in detail about all the downsides. That also has to be factored in. And at the moment, no. This is just sort of speculating optimistically about what's something optimistic that we can do. That will need to be taken into account for sure. Hallucination's an issue.